Hello, my name is Phil Varden, and today we're going to learn about sustainable heating and cooling systems. The learning objective of this lesson is to provide you with insight into the types of sustainable heating and cooling systems which exist today. To showcase this, I've selected a few real systems and will outline their characteristics so that the range of systems and where they are applicable becomes apparent. Here are some key characteristics of the systems which we'll compare. These include the scale of the energy supply, which can be large scale for large neighbourhoods or parts of cities, or small scale for individual buildings or small clusters of buildings. The quality or the temperature can also be quite different. Some systems have high temperatures or high quality thermal energy, which can be directly used in most current buildings. This is a flexible system where both old and new buildings can be served. The higher temperatures mean that the energy density is high, and therefore more energy can be moved to the right location more easily. Lower quality energy is more easily available from the environment and has benefits such that both heating and cooling can be provided, and heat losses are smaller. Next, we have heating and cooling supply. Some types of systems provide just heating, some just cooling, and some provide both heating and cooling at the same time. Depending on the supply and demand, systems can either be operated in a stable manner, but more commonly with sustainable sources, they have a variable supply and demand through time. The first example project I'd like to discuss is the world's largest solar thermal park, located in Silkeborg in Denmark. It produces a maximum power of 110 megawatts. It's connected to 22,000 houses, and it supplies a maximum of 20% of the needed heat. The solar thermal energy is highly variable and is therefore compensated partly by having storage tanks, but mostly by using a more flexible and fossil fuel derived energy. The CO2 savings are approximately 15,000 tonnes per year, and the system was built with a limited capital subsidy from the government. The second project is a large new building called Echo on the campus of TU Delft, where I work. This building was designed to be energy positive. This means not only covering 100% of its own energy needs, but also provides energy externally. The building is highly insulated, reducing the required heating and cooling. It has several passive energy features such as solar shading of the windows, which still then provide a substantial amount of light. The heating and cooling load is designed to be balanced, such that an energy storage system using the aquifers below the building is used, alongside a heat pump supplied with electricity from solar panels. Due to the high level of the insulation, there is an extremely low temperature thermal energy supply. The next project is an individual house in Delft, or rather a set of individual houses, each built with their own sustainable heating and cooling system. These houses were built in 2020 and designed to be energy neutral over a period of 1 year. This means they may have a surplus or deficit of energy at any moment, but across the whole year, these balance out. Each house is highly insulated and is fitted with closed-loop borehole heat exchangers, each measuring around 150 metres in depth. A heat pump is used when needed to provide the temperatures for both heating and cooling, which is delivered to the house via underfloor heating. Electricity is used for the heat pump, which is supplied by solar panels installed individually on each house. In this neighbourhood, there's around 150 systems spaced closely together, between around 5 and 10 metres apart. Care needs to be taken during the design to ensure that the systems don't interact with each other. Balancing the heating and cooling loads throughout the year helps with this. The final system is the first deep urban geothermal project in the Netherlands. There were several other deep geothermal projects before this in the Netherlands, but these primarily supplied the greenhouse farming industry. Both houses and commercial buildings in this project are supplied with around 1,000 different individual connections. A total of around 45 terajoules are supplied annually, which makes up a high proportion, so around 75% of the total energy supply on the heat network. The peak demand remains to be covered by gas-derived energy. So to summarise what we've learnt in this video, it's important to know that there are many different heating and cooling systems available, And as I've shown, they can differ in terms of temperature, in terms of scale, i.e. from a single house to many thousand buildings, and can have various supply characteristics. I hope to have helped you appreciate some of the key technologies and system types available and how they can be incorporated to supply heating and cooling in a more sustainable manner. Thank you for your attention.